Hello class, welcome to this video on the cycle assessment class review. So this is for the cycle 1 assessment, which covers chapters 1 and 2 in the textbook. So we're going to go ahead and cover the rest of the questions. Actually, we'll cover the entire packet, and so we'll end up covering the questions we covered in class as well as the ones that we did not get to cover. So let's do a refresher on the ones on all of them. So let's see here. We have for the first one, given xy and zw intersecting at point A, which conjecture is always true about the given statement? So we have to select multiple, or we have to select the conjecture that is true no matter what. So if we look at xy and zw, if we were to draw a random line xy and a random line zw, let's evaluate to see if this is true. Okay, so let's say this is point A in this example. And so they cross at point A, which is true. XA is equal to AY. So XA is equal to AY. Is that always going to be true? Well, in this example, it looks like it is true, but it looks like they're about the same size, right? The same distance. But remember that this is just a drawing. I could have just as easily drawn it like this, where the line goes like this. That would be ZW. Just as easily drawn it that way. And then if you look at this distance, then that no longer is equal to that distance, right? And so that's not always true. It's true sometimes, but not always. So we'll cross that out. Angle XAZ. So this is A. So angle XAZ, is that going to be acute? So is this angle acute? Well, it's not always going to be acute, right? It could be acute if I drew the line like this, and that's an acute angle. But if I drew the line like this, well, then that's an obtuse angle, right? So it's not always going to be true. All right, so definitely not that. XY is perpendicular. That means that it crosses at a 90-degree angle. So is that true? It looks like it's almost true here, but remember, like I said, I can draw the line any way I want, and it will not cross at a 90-degree angle, right? So this is not always true. Perpendicular means crossing at a 90-degree angle. So what about X, Y, Z, and W? Are they non-collinear? Meaning are they on the same line? Well, X, Y are on the same line, and Z, W are on the same line. But X, Y, Z, W are not on the same line as a whole. And so this is always going to be true for this type of problem. So we'll circle D. The next one, the figure shows lines R, N, and P intersecting to form angles numbered 1 through 6. All three lines lie on the same plane. Based on the figure, which of the individual statements would provide enough information to conclude that line R is perpendicular, remember that means 90-degree angle, to line P. So, all right, so angle 2 is equal to 90. So if angle 2 were equal to 90, does that mean that R is perpendicular to P? Well, no. That only tells you that N is perpendicular to P, because N is the one that is at a 90-degree angle, right? So that is not true. That tells you that N is perpendicular to P, which is not what we want. Angle 6 is equal to 90. So what does that mean? So if angle 6 were equal to 90, that's this angle right here, well, that would indicate that R is perpendicular to P. So yes, that is true. That is what we want. So far, so good. The next one, angle 3 is equal to angle 6. So this is equal to this. What does that tell you? Well, that doesn't tell you anything, okay? So the angle 6 is always equal to angle 3 because of vertical angles. So that tells you that vertical angles are congruent. So that tells you nothing about perpendicularity, so that's not true. Angle 1 and 6, or angle 1 plus angle 6 equals 90. So basically this plus this is 90. What does that tell us? Well, that tells us that N is 90 degrees to P. So that tells us that N is perpendicular to P, which is not what we want. So no. Angle 3 and angle 4. So angle 3 plus angle 4 is 90 degrees. That tells us that N is 90 degrees away from P. So that, again, that tells us that n is perpendicular to p, which is not what we want. All right, finally, 4 plus 5, angle 4, the measure of angle 4 plus the measure of angle 5 is 90. Tells us that those combined is 90. So that tells us that r is 90 degrees away from p, which means it is perpendicular. So that means it's saying r is perpendicular to p. So that is true. That's what we want. We want to conclude that r is perpendicular to p. All right, so number 3. Which of the following are true about the points on the number line? Okay, so we want here AB plus BC is equal to AC. Is that a true statement or is that false? So AB plus BC. So AB plus BC equals AC. Is that true? Well, yes. The distance from A to B is 4. The distance from B to C is 3. The distance from A to C is 7. 4 plus 3 is 7. So yes, this is true. Now if we repeat that for CD plus AB equals BC. So CD plus AB equals BC. So AB is 4. CD is 1. Is that going to be the same as BC? Well, BC here is 3. The distance from 0 to 3. 4 plus 1 is 5. That is not equal to 3. So that is not true. It's false. CD. Is CD equal to 1/3 AD? All right. So CD equals 1/3 AD. Well, CD is 1. AD is A to D is a distance of 8. Okay, so this is 8 and this is 1. 1/3 times 8 is 8/3. 1 is not equal to 8/3, so this is false. All right. 1/2 of AB equals CD plus BD divided by 2. So AB is 4, and half of 4 is 2, right? And then CD plus BD divided by 2. So CD is 1, BD is 4. 4 plus 1 is, so we got 4 plus 1, which is 5. 5 divided by 2 is not the same thing as 2. This is false. Now we're going to do 1/3 of AB. Well, we just said that AB is 4. So 1/3 times 4 is 4/3. CD is, we did that as 4. CD was 1 actually. So this is 4, this is 1. CD is 1. BC, on the other hand, is 3. Okay, so we have 1 plus 3 divided by 3. Well, 1 plus 3 is 4. And then we got 4 over 3. So this is true. They're the same on both sides. So we only got the first and the last one being. All right, the next one. Given the measure of ACF is 70. So ACF, so that means this whole thing is 70. Okay, so we said that ACF is 70 and measure of ACB is 16. So this angle here is 16. But it says here that this angle is equal to this angle based off of the marks here. And so this is also 16. Now with these double marks here, these double marks indicate that those two angles are equal. And so we'll call them X because we don't know what they are yet. In fact, we're trying to find that. We're trying to find BCD. So if we solve for X here, then we solve for BCD. But we know that these 4 angles have to add up to 70 degrees. We know that. So 16 plus X, whatever that angle is, which is X, and then this is another X, plus 16 has to equal 70. So 16 plus 16 is 32. X plus X is 2X equals 70. So we subtract 32 on both sides. We have 2X equals 28. Divide by 2 on both sides. X equals 14. So, and remember we said that X was equal to this angle, and which is BCD. So this is the same thing as the measure of angle BCD. So this is what we were looking for all along. 14 degrees. All right, what is the best description of an acute angle? So an acute angle, remember, is an angle. This is just a straight up definition. An acute angle is an angle that is less than 90. And then a right angle is equal to 90. An obtuse angle is greater than 90 but less than 180, like that. And then a straight angle is 180. Okay, so this is, we're looking for, okay, so we have here, oops, not more than 90, less than 90. The best description. So an angle measuring more than 0 but less than 90. So more than 0 but less than 90. What is the name of the angle formed by BA and BC? So again, this is another definition thing. This is a ray, this is a ray. Remember that an angle is formed by the joining of two rays at a point. So if we have a point here, we have ray, that's a ray, and then this is another ray. Well, notice that BA and BC have B in common. So we could call this ray BA, that's a ray. And then we have another ray here, which we call BC. Okay, so this angle is ABC or BA or CAB. Let's see here, BA, BC. So we have, it can't be BAC, could be ABC, it can't be ACB, and it can't be CAB. It has to be CBA or ABC. Which statements should be used to prove the measures of angles 4 and 6 sum to 180? So let's look at the statements here. We have, okay, so we want to prove that 4 and 6 is equal to 180. Let's see here. Angles 2 and 4 are congruent as vertical angles. So basically they're saying, okay, well, what if we use angles 2 and angle 4 as vertical angles? Okay, so they're saying, okay, they're congruent as vertical angles. And then it says angles 5 and 6 form a linear pair. So they add, linear pair means that they add to 180. So there's no way that you can get from this being congruent and these being a linear pair to all of a sudden saying that 4 and 6 are equal, right? So there's nothing tying angles 2 and 4 to angles 5 and 6. So that would not be something that you can use to prove that those purple angles are added to 180. So the logic doesn't make sense here, so this is a big question mark. Now angles 4 and 7 are congruent as corresponding angles. Okay, so now we're doing 4 and 7 are corresponding, which they are corresponding. They if you slide angle 4 down to angle 7, it's the same angle. And angle 6 and 7 form a linear pair. So because angle 4 and angle 7 are equal, so angle 4 is congruent to angle 7 because corresponding, and then angle 6 and angle 7 are basically add up to 180, are supplementary. Well, because, and remember, we want to prove that 4 and 6 are supplementary. But since 4 is congruent to 7, and 7 and 6 are supplementary, well, this means that 4 and 6 are supplementary. We can use these two statements to prove that 4 and 6 are supplementary by transitive property, right? So you can easily replace angle 7 with angle 4 because they're the same. So then we can say that angle 6 and angle 4 are supplementary. So yes, you can use those two statements to prove that they add to 180. All right, next one. For what value of x is f parallel to g? Which theorem justifies your answer? So here we want f to be parallel to g. And so that would mean that these two angles, which these are alternate exterior angles, because they're on the outside and they switch sides, alternate exterior angles are always going to be equal for lines that are parallel. And if you think about it, this is an obtuse angle. This is also an obtuse angle. So they have to be the same if these lines are parallel. So these are equal to each other. Okay, and so we want to solve. Okay, so we want to solve this. So let's go ahead and subtract 10x on both sides, add 9 to the other side, and then divide by 2 on both sides. So x equals 7. All right, so we got 7, and the theorem that we use to justify that is, well, alternate exterior angles. Those are alternate exteriors. So it's 7, it's the converse of the alternate exteriors. Now, next one, if angle 1 is congruent to angle 2, can you conclude that any of the lines are parallel, and explain? So if angle 1 is congruent to angle 2, well, that means that your angle 1 and angle 2 have to do with these two lines right here. So if those two are congruent, well, that means that these two lines have to be parallel. If they're not congruent, then that means they're not parallel. All right? Because if you think about it, if this were just a little bit bigger, like this, then that means the line would have to go like this. And then eventually the line would cross, which is no good. So the only way that the lines will never cross is if they have the same angle here. And so, yes, the lines N and P are parallel because corresponding angles. Those are called corresponding angles. All right, so next one. Peach Street and Cherry Street are parallel. So they're parallel. Apple Street intersects them as shown in the diagram below. Measure of angle 1 is 2x plus 36. Measure of angle 2 is 7x minus 9. What is the measure of angle 2? So angle 1, if you were to slide angle 1 down, then this would be the same angle as angle 1. And so notice that angle 1 and this angle 2, this new angle 1 I mean, then angle 2 add up to 180. This is a half circle. So therefore, that means that angle 1 and angle 2 have to add up to 180. So they're supplementary. And so angle 1 is 2x plus 36. Angle 2 is 7x minus 9. And we can solve. So we got 9x plus 27 equals 180. Subtract 27 on both sides. You got 153, divide by 9 on both sides, and x is equal to 17. We got to be very careful here, actually, because they don't want x. They actually wanted the measure of angle 2. So we got to be very careful, because I almost made that mistake, right? But then I backtracked and saw, well, what are they actually looking for? They're actually looking for angle 2. So we got to plug in 17 into there. I think I might have made this mistake in class, unfortunately. So I'm glad that we're going back over this problem, because this is a lesson in reading the problem. So we have 7 times, so angle 2 is 7x minus 9. So x is 17 minus 9. So 7 times 17, 17 times 7. 7 times 7 is 49. Carry the 4, that's going to be 11. So 119 minus 9, which is 110. So part C is 110. Select all the true statements if n is parallel to m. So n is parallel to m. So let's see which ones are true. Angle 2 is equal to 60. Is that true? Is this equal to 60? Question mark. Well, let's see. We know that if we were to look at this problem, you can think of this as a transversal, by the way. If you were to think of that as a transversal, well, this angle right here is corresponding to this angle. They're both acute angles. And if you were to transport that, it's the same exact angle. And so angle 2 is not 60. Angle 2 is actually equal to 20. So that's the same thing as that angle. So that is not true. Angle 3 is 100. So let's look at that. Now let's focus on this transversal. Let's think of this as a transversal now. And so if this is 60 degrees, well, that's the same thing as this, because if you transport that up, it's the same exact angle. So angle 4 is 60. Angle 3, though, they're asking for angle 3. So angle 3 is 100. All right, so well, we just said that angle 2 is 20, right? So in angle 4, we just said that that's 60. So how do we get angle 3? Well, because we know that we can get it, there's multiple ways that you can get it. We know that this is 20, so this has to be 20 degrees because these are vertical angles. So any angles that are opposite of each other are vertical. They're both acute angles too. And so this is 20. And similarly, because of these vertical angles here and here, then this is 60. And so we know that all the angles in a triangle have to add up to 180. So 20 and 60 and 3 have to add up to 180. So 20 plus 60 plus angle 3, the measure of angle 3, have to add up to 180. So 20 and 60 is 80. And so angle 3 has to be 100 because 100 plus 80 is 180. So we have angle 3. So that is true. Angle 2 plus angle 4 is 80. Well, we know angle 4 is 60. We know angle 2 is 20. So we have 20 plus 60 is 80. And yes, that is true. Angle 2 and angle 3. Well, we know angle 3 is now. So angle 2 is 20. So 20 plus 100 is equal to 80. No, that's not correct. Right? So this cannot be correct. Angle 2 is equal to 20. The measure of angle 2, we just said that. Yes, that's on here. So that is correct. So those are the 3 true statements. All right, so next question. Use the figure for questions 2 and 3. What is the value of y, and then what is the value of x? So we know that these angles have to add up to 180. So let's go ahead and do that to find y. So 46 plus 51 plus y equals 180. This here is 97. So 97 plus y equals 180. So that means that y has to be 83. Okay, so y is 83. 83 plus 97 is 180. So now we know this is 83. And so this is 83. This has to be 83 because of vertical angles. And then 83 plus 38 plus x has to be 180. Because we have another triangle there. And then 83 plus 38 is 121. And so if we solve that, we get x is equal to, so x has to be 59. 59 plus 121 is 180. So we got x and y, which here we got y and x. What is the value of x in this triangle? So we have, again, we have another triangle. So these 3 angles have to add up to 180. So we got 2x and 2x is 4x, plus 2x is 6x. Negative 33 plus 15 is negative 18. We move the 18 over. Divide by 6 on both sides. So 6 goes into 19 3 times. So we subtract, we get 1, and then 6 goes into 18 6 times. So this should be 36. If I did that correct. Oh, 3 times, not 6 times. We got 33. All right. So what is the final step in this construction? So this right here is, this construction is making a perpendicular bisector. And it's really easy to do this. So you would normally open up the compass to a little bit more than half the length. Then you would draw the arc here, and then repeat that here. And then you do the same thing here. So once you get to that final step, you just have to connect, basically use a straight edge and connect a straight line to those points. That's your perpendicular bisector. It cuts it into 90 degrees and it cuts it in half. So use a straight edge to connect points A and B to, not points A and B to GH. You don't want to connect these to G and H. That doesn't make sense. You want to connect it straight down. So that's not it. Use a compass to make a circle centered at B. No. There is no construction that can be completed. No, that's not true. Use a straight edge to connect points A and B. In order to construct the interior point of angle CAB for the angle bisector, where should you place the compass point? So in order to do this bisector, Remember, a bisector is when you cut the angle in half. So you're going to make, something that cuts this in half, right? Like that. And so in order to to figure out where that happens, you need to place the compass at point C and then, draw an arc with that compass. And then you're going to also place it at point B later on, and then draw an arc with that compass. And then where those two arcs cross, that's where you draw your your angle bisector. So you got to place the compass at points C and B in order to make these two arcs happen. So C and B. Select all the statements that describe the steps to copy XY. Remember, to copy XY, you have to use a straight edge to make a line, right? Using a straight edge. So you make a straight edge and then you measure this with the compass, and then you use that same measurement and then draw an arc, and then label that point where it crosses the line, and then this line is going to be your new line segment. I guess we can call it X prime, Y prime. Right, so so let's see all the statements that we just did. So use a ruler to draw a line. So we can use a ruler here, but we don't have to use a ruler. You can use any straight edge. So truth of the matter is this is the most correct response right now. Place a compass point at X and open the compass to length XY. That's what we did here in this step. Using the same setting, place the compass at point M. I guess they call this point M. And then draw an arc through line L. So this is line L. Draw an arc. And then mark the point N as the intersection. So they call this N instead of Y prime. Okay, but either way, that's the same step. With a setting greater than 1/2 XY, so no, we don't do a setting greater than 1/2 XY. We do the setting equal to XY. So that's not correct. All right, what is the equation of a line that is perpendicular to the line 3x plus y equals 2 and passes through 6a? Perpendicular means opposite reciprocal. So first we got to find the slope of this line. So we need to solve this equation. So we're going to solve for y by moving the 3x over to the other side. We got a negative 3x, bring the 2 over. And now this is in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. So m is your slope. This is my slope. B is your y-intercept. 2 is your y-intercept. So what we need for perpendicularity is for the slope to be the opposite reciprocal of this line. So this is the slope of the line. To convert that to a perpendicular slope, we have to flip the original slope and then change the sign of the original slope. So this is negative, it's going to be positive. This is 3 over 1, it's going to be 1 over 3. And that new slope is going to go here. And so now if you notice, that leaves to just 2 responses. So is B equal to 2 or 6? That's what we're going to find out. So now we're going to plug in x and y, because that's x, that's y. So then we plug in that into the equation here. So this is going to be replaced with 6. This is going to be replaced with 8 equals 1/3 times 6 plus b. This is the same thing as 6 over 1. 6 times 1 is 6. 1 times 3 is 3. 6 divided by 3 is 2. And then 2 plus 6 is indeed, or 2, that's a b, not a 6, I apologize. So we got 8 is 2 plus b, and so b has to equal to 6 because 6 plus 2 is equal to 8. All right, so then we can replace the b here with 6. It's funny that that was a b, but and it actually ended up being a 6, and it looked like a 6. All right, so the answer is D. Now, next one is doing parallel. So this time you're looking at a parallel line. Parallel lines have the same slope. So the slope here is 2. So the original slope is 2. The parallel slope is also 2. Okay, remember that y equals mx plus b. So we're going to place 2 there. And now we got to figure out what b is. And notice that these aren't put in the correct order. Like like we have to fix these, right? So in order to fix these, we need to convert them over to where it looks like slope intercept form, this form, mx plus b. Okay, so we know our slope is 2, and so what we're going to do is, I'm going to go with my answers here and figure out which one's right or wrong. So if you look at part A, the slope here is -2, which does not match 2. So this is incorrect right now. Now let's look at here. So for this one, we need to solve for y. So we'll subtract 2x on both sides. We get y equals -2x plus 7. We move the 7 over down, and then the -2x goes first. The slope here is -2, so this is incorrect. We don't want this to be -2. We want it to be +2. So now let's go ahead and do this one. -2x plus y equals 2. Add 2x to both sides to get rid of that -2x. So y equals 2x plus 2. This is correct. The slope is 2. That's what we want. All right, so now select all the equations that represent a line that is perpendicular. So in this case, the equations that are perpendicular to the line with this equation. So the slope of this equation is 2. So the slope equals 2, which means that we want the perpendicular slope to be, so put this over 1, flip it, change the sign from, in this case, positive to negative. So this is the perpendicular slope that we want. So clearly the slope here is not -1/2, it's +1/2. So no, this is not correct. Here the slope is -1/2, so that checks out. What is the slope for part C? Well, we got to solve it, right? So x plus 2y equals 5. Let's subtract the x over. And then we'll divide by 2 on both sides. So notice that there's an invisible 1 here. So this is actually -1/2 x plus 5 over 2. Clearly the slope here is -1/2. So that checks out. Now if you did this one, -x plus 2y equals -3. Well, then if you move the x over, that'd be plus x. 2y equals plus x minus 3. Divide by 2. There's an invisible 1 here. The slope is 1/2. So no, we don't want it to be 1/2. We want it to be -1/2. I'm going to go ahead and finish off the last part. -x minus 2y equals 9. Add x to both sides because that's a negative. So a negative and a positive cancel. -2y, don't forget to bring down that negative, equals x plus 9. This time you're dividing by -2. So y equals, this is 1 over -2, which is the same thing as -1/2. And then this is 9 divided by -2, which is -9 over 2. So the slope is negative, which means we want that as our answer. Okay, so we got those 3 answers. Now, what must be true to prove that Q is perpendicular to N? So remember that the slope, if I know the slope of Q is, say, 1/2, then the slope of N has to be the opposite reciprocal for it to be perpendicular, right? So I need to flip these and then change the sign from positive to negative. So that's what I need to know. That's what I need to do if I want to find the perpendicular slope. Now, how do I prove that they're perpendicular? Well, if I multiply the slopes together, then notice I get 1 times -2 is -2. 2 times 1 is 2. -2 divided by 2 is -1. So notice that I always get -1 when I multiply 2 slopes that are perpendicular. So in order to prove it, we would say, well, the slope of Q, when we multiply them, we get -1, or you can think of it as what we just did. If you flip it, then you change the sign, then that's going to be perpendicular. So flip it is called reciprocal. changing the sign is called finding the opposite. So we call it the opposite reciprocal or the negative reciprocal. So the slope of Q must be the negative reciprocal of the slope of N. Right? Which statement is true about the two lines whose equations are given below? Are they perpendicular, parallel, etc.? So we need to find the slope of these two lines. So again, we got to solve them just like we usually do. We convert them to slope-intercept form. So let's solve for y by getting rid of 3x. So subtract it because this is a positive right here. Bring down the negative 3x part first, and then bring down the minus 3. Now we can go ahead and divide by negative 5. So y equals 3/5. Negative divided by a negative is positive. Negative divided by negative is positive. All right, so the slope here is 3/5. Now let's find the slope of this guy. So to solve for y, add the 2x to both sides. So y equals 2x minus 8. So here the slope is 2. So they're not parallel because the slopes are not the same. They're also not perpendicular because you can't flip 3 over 5. If you flip 3 over 5, you get 5 over 3. And 5 over 3 does not equal to 2. So therefore, it's not perpendicular either. And the lines do not coincide because they don't even have the same slope. The lines intersect but are not perpendicular. That would be true. What are the coordinates of the point on a directed line segment that, let's see here, from K to L, that partitions the line segment into a ratio of 3 to 2? So the ratio here is 3 to 2. We have here a directed line segment K. Let's go ahead and draw it out. 1, 2, 3, 4, 5. 1, 2, 3, 4. That's K, which is negative 5, negative 4. And then L is 1, 2, 3, 4, 5, 1. So this is my line segment. And then you want to say, where should I put a point to break it into 3 parts on the left side, 2 parts on the right side? First off, you need to convert this to a fraction. In order to do that, you take that first number, put it in the numerator, and then combine those two numbers, put it in the denominator. So 3 plus 2 is 5. So my fraction here is 3/5. Now, what you're going to do next, you're going to find the horizontal distance from K to L and the vertical distance from K to L. The horizontal distance from K to L, let's go and write down the coordinates of L. So to find the horizontal distance, you subtract the 2 coordinates there, absolute value. That'll give you 10. That's the horizontal distance. Vertical distance, subtract the y's and the absolute value. It's going to be 5. And then what you want to do is you want to multiply each of those numbers by 3/5. Okay, so, and that'll give you your vertical change and your horizontal change. So let's do horizontal change first. So the 10 number that I got multiplied by the 3/5 number that I got earlier, the 3/5 number here. Put this over 1, multiply straight across. 30 over 5. 30 divided by 5 is 6. That's my horizontal change. My vertical change, I got to do 5 times the fraction, 3/5. Put this over 1, multiply straight across. 15 divided by 5 is 3. So this means that I'm going to go 6 over horizontally and then 3 over vertically from point K. Because remember, you're going from K to L. So from K, I'm going to translate. I'm going to move over 6 to the right. How do I know it's to the right? Because I want to go from K to L. So I need to go from 6 to the right and 3 up. So I need to go 6 to the right, 3 up. And then that point is my point that partitions the line segment in this ratio, okay, the 3:2 ratio. Okay, so where exactly is 6 right and 3 up? You're just going to add that to k. Okay, so the coordinates of k are -5 and -4. So let's go ahead and do that. So -5 plus what? Plus the horizontal change, 6. So you're adding that to the x, and that moves it to the right. The vertical change is 3, but the original y is -4. So you're going to do -4 plus what? Plus the vertical change. And then the new coordinate is 1, -1. All right, if a point PQ is 1/3 of the way from A to B, what are the values of P and Q? So this is another partitioning problem. So we're 1/3 of the way. So let's go ahead and find the horizontal and the vertical distance. So the horizontal distance, you got to subtract the x's. So 12 minus -3, which is 15. You can count the spaces as well. Be careful, the spaces here are going by 2. So 2, 4, 6, 8, and so on. Now the vertical distance, subtract the y coordinates, 4 minus -2, which is 6. All right, so now you're gonna, that's that, and then you're gonna multiply each of those distances by your fraction 1/3. 6 over 1, multiply straight across, 6 over 3, which is 2. 6 divided by 3 is 2. So that's going to be my vertical change. This guy, we're going to multiply by the same fraction, 1/3, put it over 1, multiply straight across. 15 over 3 is 5. All right, so then you're going to take each of those coordinates and you're going to move from A to B. You're going to move A by 5, and then you're going to move it up 2. Okay, so the coordinates of A are -3, -2. So -3 plus the 5, -2 plus the 2. And so you get that's a +2, that's 0. So the coordinates are 2, 0. So that means P is 0, P is 2, because this is P, and this is Q in the problem, because it says PQ right there. All right, the next one, point A has coordinates -5, 3. If point 16 is 3/4 of the way from A to B, what are the coordinates of point B? Okay, this is the same, this is actually a harder version of what we just did here. Okay, so let's go ahead and go over this type of problem. So again, harder problem because this time they're asking you for what this coordinate is instead of the middle coordinate. Okay, so in order to do this, let's go ahead and show you all the steps. The steps are going to be slightly different here. So we got A, just -5, 3. Point 16, that's point P. And then it says it's 3/4 of the way from A to B. So that means that this is the line from A to P. B is somewhere out here, right? Somewhere. And we don't know what it is. We don't know what the coordinates are. But we do know the coordinates of P, which is 16. And we know that is 3/4 of the way. So this is 3/4 of the way. Okay, so what we need to do is find the distance from A to P in the X and from A to P in the Y. Okay, so let's go ahead and do that. So we need to figure out this horizontal distance and this vertical distance. So the horizontal distance here is 1 minus -5 is 6. The vertical distance is 6 minus 3 is 3. Okay, so we got the 3 and the 6. So now what we need to do is set up sort of like an equation. We know that this total distance from A to B is some number that we got to find. Like, we got to find that number. Like, what is that total distance from A to B? Because if I find that total distance, then I can go ahead and figure out what B is. And then I want to figure out this total distance as well, right? And so we know that this 6 is 3/4 of this blue. The 6 is 3/4 of this blue, and this green 3 is 3/4 of this big green. Okay, so how do I find it? Well, let's set up an equation. I know that I need to find 3/4 of this total. 3/4 of this total. Let's call that total. Call this big blue one the total vertical distance. Okay, just to give it a name, total vertical distance. Let's call this big green one total, or no, total horizontal, because this is horizontal, not vertical. I apologize. And this green one is the vertical distance, so we'll call that total vertical distance. Now, okay, so now 3/4 of this big one is equal to the small one. Okay, so let's repeat that again. So the big one, whatever the big one is, 3/4 of that is going to give me 6. If I were to cut it by 3/4, it would give me the smaller one. And so now we can solve this equation. Let's multiply by the reciprocal here to cancel those out. 6 times 4 is 24. 1 times 3 is 3. 24 divided by 3 is 8. So the total horizontal distance is 8. Now let's set up an equation for the vertical distance. So 3/4 of the vertical distance is equal to 3. Multiply by the reciprocal. Put this over 1, multiply straight across. This is 12 over 3. 12 divided by 3 is 4. So the total vertical distance equals 4. All right, so then what do we do with that? With those two numbers? That means that you're going to move from A to B by this direction. You're going to move from A to B right by, what was the total horizontal distance? 8. You're going to move right by 8. So 8 spaces. And then you're going to move the green, which is 4 spaces. So you're going to move 4 spaces up. 1, 2, 3, 4. And that'll get you where B is at. Okay? So let's take the coordinates of A. And we're going to move it. So we're going to move it 8 to the right. And 4 up. Or yeah, it was 4 up. That will give us 3, 7. So those are my coordinates of B, 3, 7. Okay, so different process because we're trying to work backwards instead. So those are the more difficult types of problems. All right, so what are the coordinates of the point 4/5 of the way from A to B? So A to B, again, so we got to do what we did before. This, this. The horizontal distance is 6 minus -4 is 10. The vertical is 6 minus -4 is also 10. We got to multiply those numbers by 4/5, the fraction that they give us. So 10 times 4 is 40. There's an invisible 1 there. 1 times 5 is 5. 40 divided by 5 is 8. So this is 8. We multiply this by the same fraction. Put this over 1, straight across. 40 divided by 5 is 8. So we got 8 as well. So we're going to be moving from A, we're going to be moving 8 right and 8 up. So let's do that for A. So A is originally this coordinate. So if I move it, 8 to the right, 8 up. Coordinates here are 4, 4. All right, a city map is placed on a coordinate grid. The post office is located at the point 535, and the library is located at L 1510. Fire station is located at 925. What is the ratio of the length of PF to the length of LF? Okay, so let's go ahead and visualize this. So we have, let's go by fives, 5, 10, 15, 20, 25, 30, 35. Okay, so this is 535. So this is where the post office is. The library is located at 1510. This is 10, so this is the library. And the fire station is at 925. So something like that. It's pretty close to the 10 on here. So this is the fire station. So what is the ratio of the length of PF to length LF? Okay, so basically they're located all on a straight line. And they want to say, okay, well, what's the ratio of this to that? Okay. So they want the ratio of PF to LF. All right, once we find that, then we're good. So to do that, well, this is the post office. This one was the fire. Okay, so we got to figure out the distance from, basically we got to figure out the distance from P to F, and then the distance from F to L. And then once we find the distances, then we're good. We can just take the ratio. Now you could do the distances in the X or the distances in the Y. Either one is fine. So let's go ahead and do the distances in the X, or let's do the distances in the Y. Okay, so let's go ahead and do the vertical distance here, and then the vertical distance here, and then figure out what that ratio is. Okay, so what's the vertical distance from P to F? You just got to subtract the Y values. So the Y value for P is 35. The Y value for F is 25. So 35 minus 25 is 10. So this distance is 10. Now for the green, from F to L. So the Y coordinate of F is 25. The Y coordinate of L is 10. So 25 minus 10 is 15. All right, so this is 15. So what's the ratio from 10 to 15? So that's my guy, 10 to 15. And then, but then of course that doesn't match up to the answer, so I got to reduce it, right? So I can go ahead and divide 10 and 15 by 5. And then that will give me 2 and 3. So 2 to 3 ratio. All right, guys, that's going to do it for the video. I hope you found this useful. And as usual, I'll see you in the next one.